For example 9, the above figure shows a coin resting on a book. Okay, it shows a coin resting on. You can change this if it's not clear and you no changes to resting on a book. Tilted at an angle of theta. You can see the theta here with the horizontal. So you can see this is our horizontal here. You can see the coin here resting on a book. The book is tilted at an angle theta. When theta is increased, you can change this to, you can write W here. When theta is increased to 13 degrees, so at this point theta is equal to 13 degrees, the coin begins to slide down the book. What is the coefficient of static friction between, this is B here, what is the coefficient of static friction between the coin and the book? What is the coefficient of static friction between the coin and the book? So we're going to try to solve this problem together and then see what's going on. First of all, when you are faced with problems like this, you want to create your coordinate axis. Okay, you want to represent it on an XY plane so you can easily translate it, see what is going on. So this is what you want to do first of all. All right, now let me quickly explain some important things here. This book, let's assume this is the book represented with this dot here. I mean, this is a coin rather resting on the book. All right, so the book is on this horizontal at an angle 13 degrees, and this is a coin here. So on this particular coin, the first working on this particular coin, you know, if you draw your coordinate axis on with regards to this coin, you're gonna have it like this. Now that your horizontal axis is this way, now you're gonna have the perpendicular axis like this. Can you see that? Horizontal plane. Okay, so when you do that on this particular coin, there is going to be another perpendicular line that with respect to the weight of the body is going to be this way. The weight of the body cannot be on this line. The weight has to be this way, perpendicular this way. All right, so this weight is forming a perpendicular line across this particular triangle that we are creating on this XY plane here. Our theta here is 13 degrees, don't forget, right? So, and that means this angle here is going to be about 90 degrees, isn't it? Yes. With this weight. So if this is 13 degrees and this is 90 degrees, what is going to be this angle here? 60. This angle will be 77. All right, because all the angle in this triangle has to be 180. If you have 90 here, we have 13 here. You just add these two together and take them from 180. All right, and then you have 77, or these two angles must be 92 to make the whole triangle 180. So you just take 13 from 90 to have our 77 here. So you have, all right, so if this is 77, this is 13 here. According to the law of mathematics, the angle here also is going to be 13. Okay, all right, so we have our coin here. Now the coin is going to slide down. If the coin is sliding down, that means the force pulling the coin down is going in this direction. So the frictional force will be up. That is why you can see we have Fs here as our static frictional force preventing this coin from going down. Can you see that? So that is the first preventing this coin from going down. So what you want to do right now is to find the horizontal component of all the forces we have. For example, you see we have the weight here, we have the frictional force here, we have the normal force here. So we're going to try to find the horizontal component and the vertical component of all those forces. We're going to pay attention to what we have and what we do not have, and then we're going to use all the things we have. Now what we're looking for is mu s, which is the coefficient of static frictional force. All right, let's take it a step further. First of all, you do know that the summation of forces in all, our plane is going to be equal to 0. The horizontal plane, the XY plane, summation of all the forces acting on the body must be equal to 0. What you can see here, the weight is acting on the body, the frictional force Fs is acting on the body, the normal force N is also acting on the body. So total force acting on this body, when you add them together, they must all be equal to 0. All right, so total force acting on the body will be equal to W plus Fs plus N, and they must all be equal to 0. Okay, then keeping this in mind, you can then go ahead and find summation of f of x. what is going to be our summation f of x? Summation f of x normally is supposed to be the horizontal force acting on the body, isn't it? So how do we find that? Before now, we usually say that summation f of x. How many horizontal forces do we have here? Fs is going to be horizontal because this is on the horizontal plane, where on the book that is placed horizontally. So Fs is going to be horizontal. That's the first S, first F we have. So we have Fs here. Now minus W sine theta equal to 0. Okay, in this particular case, what is going to be our theta? So you have to ask yourself, which of these thetas do you want to consider? If you are considering 13 degrees or considering 77 degrees, the way you're going to treat this is going to be different. Okay, before now we usually say that to find horizontal component is just going to be the force multiplied by cos of the horizontal angle, isn't it? So the angle we have here is 30. If you are going to use 13 degrees as the angle, you are going to use sine. If you are going to use 77 degrees, you are going to use cosine 77. So the angle we want to use here is 77 degrees if you want to use cos. But if you use sine, you are going to use 13 degrees. At the end of the day, sine 13 would be the same thing as cos 77 degrees. All right. So if you have this, you have summation fx equal to fs minus sine theta equal to 0. Why do we have minus here? Because this weight you're looking at here is what we want to convert to the horizontal component. This weight is what we want to convert to the horizontal component. Okay, so to do that, this weight is going to have to come this way, and this, if it comes this way, this is going to take us to negative x-axis. Can you see that? So the horizontal component is going to be on the negative axis. And if the weight is coming, this way, that means we are paying attention to this particular angle. This is the angle we are dealing with. So it's just going to be W cos 77. If you're going to use sine, it's going to be sine 13. So I haven't said that if you rearrange this Fs, if you take minus W sine theta equal, to the opposite side will be equal to sine, it becomes Fs equal to W sine theta. Let's take it a step further and see exactly what happened. So once you do that, you keep this somewhere, and then you can go ahead and try to find the vertical component of the force acting on this on the body. All right. So what you will find here is that the sum of all the vertical components should be equal to 0. Okay. Sum of all the horizontal components is equal to 0. Sum of all the vertical components should be equal to 0. Sum of all the forces should be equal to 0. Okay. So the vertical component, the first one we have is our n, which is what you can see here. So you have n, right? And then if you want to convert this weight to vertical component, because this is W is also going to be acting on the body. So if you convert it to vertical component, that means it's going to be coming this way, isn't it? So if it's coming this way, to form a vertical component, it simply means it's going to be W sine 77. All right, it's going to be W sine 77. If you want to use cos, it's going to be W cos 13. All right, if you want to use cos, it's going to be W cos 13. But if you want to use 77, it's going to be W sine 77. So pay attention to those. So you have the summation of f of y would be equal to n minus W cos theta. Everything will be equal to 0, and then eventually what you have is n equal to W cos theta. If you carry out mathematical operations, you carry out mathematical, arithmetic operations on these expressions, you have n equal to W cos theta. Once you have that, you can see now that we have two equations. You can see we have this equation n equal to W cos theta. You can see that we have Fs equal to W sin theta. The next thing you want to pay attention to is this. We said earlier, if you remember, that our mu x, our f, right? Fx max, if you remember, we said is equal to what? It's going to be equal to mu s multiplied by n, isn't it? If you remember that, you can say that our mu s now would then be equal to our f all divided by our n. That is what we have here. Okay, so if we have this way, and we know that our f is equal to fx max here, we can just quickly rearrange this the way it is here. All right, this becomes mu x max equal to f max equal to fx max over n. All right, so this becomes fx max over n. So this is what we have here. So what is our fs max? We know it to be w sine theta. What is our n? W cos theta. This w, we cancel this w out. We are left with just sine theta over cos theta. What is sine over cos? It's going to give us tan theta, isn't it? So if we have tan theta, we are using sine theta. So that means we are using sine 13. 13 we are using here. So if you have 13 here, that gives you tan 13. This is going to be equal to tan 13. All right. From here, you can just say that whatever you obtain as your tan 13 becomes the coefficient of your static friction that we are looking for. So the coefficient of static friction we're looking for becomes 0.23. All right. I'm going to go to the next example, right? This is example 9, and I think we found what we are looking for. So we can go on to the next example. We can go on to the next example now.